Finding the second derivative of a plane curve given by a set of parametric equations becomes important when you want to sketch the graph, find concavity, things of that nature. Remember that if you wanted to find the second derivative of a function y in terms of x, we write that this way, the second derivative of y with respect to x, and really what we're doing is we're just taking the derivative of the first derivative. Well, in the case of a set of parametric equations, say given x equals f of t, y equals g of t, remember that the derivative of y with respect to x can be found by finding the derivative of y with respect to t divided by the derivative of x with respect to t. In any event, we're finding the derivative of y with respect to x, and then we're doing the derivative with respect to x again. So, essentially what we do here for a set of parametric equations is we find the derivative of y with respect to x, and we take the derivative of that with respect to t. That would be the second time that we're taking the derivative. And then we're actually dividing again by dx dt. So our second derivative of y with respect to x is the derivative of y with respect to x, taking the derivative with respect to t again, and then dividing by the derivative of x with respect to t again. So quickly, for an example, if we say x is equal to t cubed plus 1, and y is equal to 4t to the fifth plus t, the first derivative, dy dx, is equal to dy dt divided by dx dt. That's just for the first derivative. So in this case, dy dt is 20 t to the fourth plus 1 divided by dx dt is 3t squared. Well, we could break this up and simplify a little bit. This would be 20 t to the fourth divided by 3t squared plus 1/3 times t to the negative 2, if you will. And so this is the same as 20 divided by 3t squared plus 1/3 t to the negative 2. This is the first derivative of y with respect to x. For the second derivative of y with respect to x, we follow the rule. It says you take the derivative of the first derivative with respect to t, and then you divide that by dx dt. So that's what we're going to do. So we're going to take the derivative of the derivative with respect to t. Well, we already know our derivative is 20 divided by 3 t squared plus 1/3 t to the negative 2. So the derivative of that will be 20 over 3 times 2t minus 1/3 times 2t to the negative 3. And then we divide that by dx dt. Well, dx dt, remember, we found earlier, dx dt is 3t squared. So simplifying some of this, 20 over 3 times 2 is 40 over 3. times t minus 2 times 1/3 is 2/3, t to the negative 3, and then divided by 3t squared. We can break this up into two separate fractions, 40 divided by 3t divided by 3t squared minus 2/3 t to the negative 3 divided by 3t squared. T and t squared would cancel and leave a t in the denominator. 3 is the same as 3 over 1. If you multiply by the reciprocal, that's multiplying by 1/3, so we get 40 over 9 t to the negative 1. Similarly here, we're going to, you could think of this as t to the negative 3, and then divided by t squared, you subtract the exponents. So this would be minus 2 over 9 t to the negative 5. So finally, our second derivative with respect to x is 40 over 9t minus 2 over 9t to the 5th. So again, remember the idea for finding the second derivative is that you take the derivative of the derivative and then divide by dx dt.